Hi everyone, and welcome to Getting Started in WCRL. I'm Sam, and this will be the first video in our 4-part tutorial series on how to create a bot for the Watson Combat Robotics League. The second video in our series will cover the design process, including choosing a design, using CAD software, and good design practices. The third video will go over electronics and coding using an Arduino along with the WCRL PCB. Our last video will be a guide on the 3D printing and assembly of your bot. We plan on adding more videos, such as a guide for using the Raspberry Pi Pico, in the future. We recommend watching the whole series before starting the design process, as doing so will give you the most complete picture of what goes into a WCRL bot. So first, what is WCRL? The Watson Combat Robotics League is a BattleBot-style competition founded and run by students at Binghamton University in the Watson College of Engineering and Applied Science. Please note that we welcome all majors, and you don't need to be in Watson to join or participate in WCRL. The competition requires teams to design, build, and compete small-scale 3D printed combat robots. Next, for some WCRL tips. We recommend working in a team, as it will allow you to split the workload of creating a bot and makes the process that much more fun. The average cost of a robot is around $50 for the essential parts that you need to buy, as WCRL provides many parts to competitors, including lots of the electronics and free 3D printing at the ETS on campus. However, note that each team is limited to a budget cap of $125 for the total cost of parts on the bot, excluding spare parts. Here are some important links for all competitors. Please join our Discord server to register as a team, find teammates, and get all WCRL updates including match information. Our GitHub repository also has tons of great resources such as example bot bill of materials, sample code, and written guides to complement these videos. Be sure to also get familiar with the WCRL rules on GitHub, and all these links will be in the description. Before you start designing your bot, you should know some of the major parts that you need. A chassis is the base of your bot, which usually houses all of the electronic components and where all parts ultimately attach to. A competition attachment is a movable, 3D printed component that is attached to a bot that could seriously hinder, halt, or otherwise disrupt the operation of another bot. In other words, it's a bot's weapon. The microcontroller is the brains of the bot and is what will use your code to control the bot based on your inputs. Currently, we provide support for the Arduino Nano and the Raspberry Pi Pico. A drive motor is what will drive your wheels or other means of motion. Most bots have multiple drive motors, often 2 or 4. The picture here shows a DC drive motor, which is controlled by a DC motor driver, although other kinds of motors, like brushless motors, can also be used. A combat attachment motor is used to power your combat attachment. This picture shows a brushless outrunner, which can spin at very high speeds, but other kinds of motors, like servo motors, may be better for certain applications. Finally, a wireless controller module is used to allow your microcontroller to communicate with a wireless controller, like your phone. These are not all the parts that go into a bot, and more will be covered in the later videos. Here are some different examples of robot designs for you to start thinking about. A vertical spinner spins a competition attachment to hit an opponent vertically. A horizontal spinner spins a competition attachment to hit an opponent horizontally. A flipper uses a competition attachment to flip an opponent on their side or back. These designs have all been proven to be effective in WCRL competitions, but we want to encourage competitors to think outside of the box and create a unique robot that hasn't been seen before. Brainstorming a new design with your team is an essential part of WCRL, and this slide is just meant to provide some ideas of existing designs that you can improve on. That's all for this video, and please continue watching our series as we get into the more technical aspect of bot design in the next video. If you have any questions, you can email wcrl@binghamton.edu. Thanks for watching.